Consider a disk rolling down an inclined plane. So the contact point initially here, when a disk rotates, ends up at the top, and the center of mass of the disk translates to this point. Now the no-slip condition means that the change in the position of the center of mass is equal to the arc length from the new contact point to the initial contact point. And delta S can be determined using the arc length formula, where the change in angle is d theta. And then dividing through by delta t, and then taking the limit as delta t approaches 0, we have a relationship between the velocity of the center of mass and the rotational velocity at the contact point, and that's equal to the radius of the disk by the angular velocity. And if we differentiate this with respect to time, we obtain a relationship between the accelerations. So this rolling motion can be visualized as the superposition of the translation of the center of mass, which is the same everywhere on a disk, and then plus the rotation. So we have the rotational velocity at the contact point equal in magnitude to the velocity of the center of mass. And that's equal to the rolling motion. So we see that at a particular instant in time, the instantaneous velocity at the contact point is 0, because the translation and rotation of the disk cancel each other out.